proving trig identities at almost 5 o'clock on a Friday. It's ridiculous. Remember, an identity is a mathematical equation that is true for all values within the domain, right? And so the important thing within the domain means we also have to state restrictions. I don't have a pen on theta or theta. Hang on, get a pen. The line, it's starting over. Prove the following identities, also state the restrictions on theta. So pick a side, any side. We want to prove that 1 plus tan squared is secant squared. It's one of the Pythagorean identities. So the more complicated side in this case, I suppose, is 1 plus tan squared. So the left side is 1 plus tan squared theta. But tangent is sine over cos. And tan squared then is sine squared theta over cos squared theta. Now if we're going to add these two guys together, the denominator is cos squared theta. So we have to write 1 as something over cos squared theta. So it will be cos squared theta. See, what's this equal to? That's 1. Forget this for a sec, and then we just have plus sine squared theta. Extend this out. Things should cover up. Scooch down a smidge. What's cos squared plus sine squared? That's 1. So we have 1 over cos squared theta. What's 1 over cos squared? That's secant squared. And that's the right-hand side. So we're done. So what you want to do, basically, generally, is take the more complicated side and turn it into the easier side. Take the left side, work it until it becomes the right side. Another Pythagorean identity, right? And just remember, every time you see a squared, you need to, oh wait, restrictions. So cosine can't be 0, right? So by now, we sadly know that it's pi over 2 plus n pi, where n belongs to the integers. Okay, so at some point, at this point, you could have done the restrictions, just realizing that cos are at this point. 1 plus cotan squared. The left side is 1 plus cot squared theta, which is 1 plus, okay, cotangent squared is cos squared theta over sine squared theta. Wow, nice. It's been a while. Tablet writing. The common denominator is sine squared. 1 is sine squared over sine squared. Right? What's this? It's 1. Forget this. What's this? It's cos squared over sine squared. So if you cover this up, you're just left with that. So it's good. Cos squared plus sine squared, or sine squared plus cos squared is 1. 1 over sine squared theta is cosecant squared theta, which is equal to the right side. Okay, so huzzah, hooray, woot. Proves, those were 2 of the 3 Pythagorean identities. Prove the following identities, and oh, restrictions, damn it. Restrictions, so the restriction here is sine. Sine cannot be 0, so theta is not n pi, where n belongs to the i's. Secant theta is sine theta, tan theta plus cos theta. So this side, there's not much you can do with this, right? I mean, it's secant, it's 1 over cos. So let's go to the right side. The restriction here is going to be that cos can't be 0, right? Sine over cos. So tangent's undefined at pi over 2 plus n pi. But right side, sine theta, tan theta. So start with the act, just rewrite the right side. Rewrite the right to be in the right. So I'm getting all fractional here. So tangent is sine theta over cos theta plus cos theta. Throw that over a 1 we're going to need. So we're going to get sine squared theta over cos theta plus cos theta over 1 you don't need that, but common denominator is going to be cos theta. This is already over cos theta, so we just go sine squared theta. To put this over cos, we multiply by cos over cos. So this becomes cos squared theta. Sine squared plus cos squared is 1. We get 1 over cos theta, which is secant theta. Which is the left-hand side. And the restriction being, of course, that cosine can't be 0. Cosine can't be 0, cosine can't be 0, cosine can't be 0. And that restriction leads us to theta is not pi over 2 plus n pi. To be 1 plus cotan squared theta over 1 plus tan squared theta is equal to cotan. So we just cross off the 1s and the tan squared, and you can't do that. So left side is obviously the more complex side here. I'm trying to write 1 plus tan. I wrote 1 tan. Okay, again, anytime you're looking at squares, pull out your Pythagorean identities. 1 plus cotan squared is cosecant squared theta. 1 plus tan squared is secant squared theta. 1 over cosec, that's 1 over sine squared theta. Secant squared is 1 over cos squared theta. There's a lot of restrictions here, right? Which is the you can't be pi over 2 plus n pi. You can't be pi plus n or n pi. Okay, we'll get to that in a sec. So I have 1 over sine squared theta times, flip it, cos squared theta over 1, which is cos squared over sine squared, cos squared theta over sine squared theta, which is cotan squared theta, which is the right side. We are on the side of right. And so you cannot have sine be 0, you cannot have cosine be 0. So cosine is pi over 2 plus n pi. And sine, that's not equal, so don't want that, is n pi. Okay. It's going to be much shorter. C. Sine squared x secant squared x is equal to secant squared x minus 1. Okay. Well, secant squared x minus 1, there's a... Again, right, we're sort of looking ahead, right? I mean, we know that 1 plus tan squared is equal to secant squared. 1 plus tan squared. So if we subtract 1, right, we get secant squared minus 1 is tan squared. Okay, so if I can then get a tan squared, I can turn it into this. So I want to be able to turn this into tan squared. So that's where we're going. Right, we're going to go with the left-hand side. We're going to try and turn that into tangent. So we got sine squared x, secant squared x. So not much we do with sine squared, but secant squared becomes 1 over cos squared x. And that becomes sine squared over cos squared. Sine squared x over cos squared x, which is tan squared x, which is, right, secant squared x minus 1, which is the right-hand side. So that's all good. And what do we have to watch out for? We cannot have secant be undefined. And secant would be undefined. So we can't have the cosine be 0, and we cannot have secant squared be positive 1. And that's going to happen when cosine is 1 or negative 1. Okay, so I just forgot everything I said. So cosine, so oops, not theta, is it? It's x. Control Z. So x cannot equal pi over 2 plus n pi. Okay, so that's that being 0, but I don't know, cos squared can be 1. That's fine. It would just be 1 minus 1. That'll be 0. Well, that's it. We're done. The only thing we can't have is we can't have cosine be 0, right? And cosine 0 here is bad too, because then that would be undefined, but that's it. 1 plus cotan theta over cosecant theta is equal to sine plus cos. There's not really much you could do with sine plus cos, right? There's actually nothing you can do with sine plus cos. So if you're going to have to pick a side, pick the left side. And rewrite it. Right? Just so if anybody's looking, they don't have to look up here. They just look here and say, okay, you have said that this is this. Commonly, we turn things into sine and cos. So cotan is cos theta over sine theta over, yay, complex fractions, 1 over sine theta. This has to be added. It will have a common denominator of sine theta. 1 needs to be turned into something over sine theta. Look, it's 1. Okay, and at the same time, so we've got that done. Let's bracket this. We can multiply this by the reciprocal of this. Oh, look, we're done. Hooray. Undefined-ish stuff. So cosecant can't be 0, but guess what? Cosecant can't be 0. Cotan can't be undefined, which happens when the sine, oh look, and cosecant, yeah, okay, so that can't be undefined either, which happens when sine theta is 0. So it's n pi, where n belongs to the i's. The i's have it. Sorry. No sneeze button. Now, doesn't this just look like something that I should be cross-multiplying? You can't do that. Okay, so we are going to solve, we're going to prove this identity. And the way we're going to do it is, because your choice really is one or the other, but I'm going to do this. I'm going to say the right side is sine x over 1 plus cos x. And then the thing we're going to do is this. We're going to multiply by the conjugate of this. So we're going to take sine x over 1 plus cos x. I'm going to put appropriate bracketry in there. Times 1 minus cos x over 1 minus cos x. And you say, why are we doing this? Well, look in the denominator. You're going to get 1. You got minus cos squared. 1 minus cos squared x is sine squared x. And look, we want to get it. Well, we want a sine x, but we'll have a sine squared. That's a start. Okay? And then how do we get a 1 minus? Oh, hey, we're going to have a sine squared x on the bottom. We're going to cancel it with the sine x up top, giving us just a sine x and giving us this and that. And then it's done. It's so done. It's almost not worth writing it all out. Sine x, 1 minus cos x. Don't expand this. 1 minus cos squared x. Sure, write the 1 on top of the write the write the minus on top of the 1. That's a good one. 1 minus cos squared x, which is, don't expand this, What's 1 minus cos squared? Sine squared. Drag this down a bit. What happens? This sine squared takes out the square. Sorry, this sine cancels, right? And that's a 1, and that's a 1. We end up with 1 minus cos x over sine x, which is the left-hand side. Hooray! And what can't we have? We cannot have sine be 0. And we cannot have cos x be negative 1, which actually kind of happens when sine is, where is cos x negative 1? Is it 2? It's at pi, so we're good. Okay, so x cannot be, right, can't be 0, n pi. And cos x can't be negative 1, but that only happens at pi and 3 pi and 5 pi, and we've covered all the multiples of pi. So we're done. Oh my god, really? 16 minutes? Like the last one was like an hour. I'll just to heck with it. In for a penny, in for a pound. I'm just going to finish this. There's no, I'll be back Wednesday. We'll do this together because, wow, okay, things got a little more complicated here. Well, it's not cotan that's complicated, is it? It's the cos double angles. It's okay, right? We have double angle identities. We can use them. So the right side is 1 plus cos 2 theta. All over. So watch your all overs. Sine 2 theta. Right. So we have the various, now you have to look at your formula sheet, right? So cos 2 theta can be expressed in 3 different ways, right? But sine 2 theta can't. So let's do that first. So let's just go sine 2 theta is 2 sine theta cos theta. And now we'll decide what form do we want this to be in. So what if we went cos squared minus sine squared? Right, let's try that, because I think if we went cos squared minus sine squared, then we can get like a 1 minus sine squared. All right, let's try that. 1 plus cos squared theta minus sine squared theta. Okay, so you see where I'm going here? We're going to get 1 minus sine squared, which is going to be like 2 cos squared. It's going to be cos squared and then 2 cos squared, and then the 2's are going to disappear. And one of the cos is going to take off that cos, and it's whatever. We're going to have with cos over sine, which is cotan. But here, let's do it. So 1 minus sine squared theta plus cos squared theta. So all I've done is rearrange, just change the order, right? 1 minus sine squared plus cos squared over 2 sine theta cos theta. So 1 minus sine squared is cos squared plus cos squared theta over 2 sine theta cos theta, which is 2 cos squared theta over 2 sine theta cos theta. 2's, okay, this cos, that becomes 1, that's gone, which is cos theta over sine theta, which is cotangent of theta, which is the left side. We're done, except for, oh, well, that's kind of interesting. We can't have 2 theta. We can't have 2 theta be 0, nor can, what's cotan? Cos over that. We can't have 2 theta be 0, we can't have theta be 0. So 2 theta, what the heck does that do? That's like some kind of a stretch. It's horizontal by a half. All right, so then theta, instead of not being n pi, it will not be a half of n pi. So it's n pi over 2, where n belongs to the i's. Right, and that covers off anything that would make cotan undefined. Okay, last one. The sine of beta minus pi over 2 is the negative cosine of beta. Well, negative cos beta isn't all that complex. So we're going to start with the left side, which is the sine of beta minus pi over 2. But we have a sum and difference. Sine beta cos pi over 2 minus cos beta sine pi over 2 sine beta. The cosine of pi over 2 is 0. Cos beta, the sine of pi over 2 is 1. So we've got negative cos beta, which is the right-hand side. Check it off. And you know what? There's no restrictions because there's no denominators. So beta belongs to the reals. So real. Yeah, exercises. What is it? Edmodo. I'm pretty sure that probably says. Well, first of all, it's not even Edmodo. It's Schoology. Right? Which is actually pronounced Schoology. Do all your work on a separate piece of paper. Okay? There is no room here, and you must on a separate piece of paper, on many separate pieces of paper. Many separate pieces of paper. Don't try and squeeze stuff in. Show your work. Use the space. State the restrictions. And we will give you possible solutions. There's more than one way to do these, so it's just possible solutions. And this is done.